Welcome to Module 2. In this module, we define digital measurement, reporting, and verification. People often call this dMRV. Measurement, reporting, and verification is the process of tracking climate actions. We call it MRV. Digital MRV replaces manual steps with technology. It collects, processes, and verifies data with far less manual handling. The core promise of dMRV is that it lowers transaction costs. It also improves data accuracy. Finally, it enables faster and more credible issuance of carbon credits at scale. A carbon credit is a permit that represents 1 ton of carbon dioxide removed or reduced from the atmosphere. Issuance is the official creation of these credits. Digital MRV helps make this process faster and more reliable. It changes how we work throughout the carbon project lifecycle. A lifecycle is the series of stages a project goes through from start to finish. Digital MRV makes each stage more efficient. Digital MRV combines several modern technologies. It uses satellite imagery to observe land areas from space. It uses artificial intelligence to process large amounts of data quickly. It uses Internet of Things sensors to measure physical conditions on the ground. We also call these IoT sensors. Finally, it uses distributed ledger or blockchain records to store data securely. A blockchain is a database that records transactions in a way that cannot be changed. These technologies work together to automate tasks. In the past, people did these tasks by hand. They wrote down numbers and typed them into computers. Now, machines collect and process the data directly. This removes many human errors. It also speeds up the entire process. To understand how this works, we must walk through the 6-step digital workflow. The process begins with data capture. During data capture, sensors or satellites collect raw activity data. This produces a raw dataset. Next is standardization. In this step, the system formats the raw data into consistent units and structures. This produces a clean, uniform dataset. The third step is quality control. Here, automated checks identify anomalies or missing values. An anomaly is a data point that deviates from the expected range. This step produces a validated dataset. These first 3 steps prepare the data for calculations. They ensure the data is accurate and ready to use. The system handles all these steps automatically. The 4th step is calculation. Here, the system runs the standardized data through the project's emission reduction formulas. This produces the final emission reduction figures. The 5th step is independent verification. During this step, a third-party auditor reviews the data trail. This produces a verification statement. An auditor is an independent expert who checks the work. The 6th and final step is registry issuance. Here, the verified credits are minted and tracked. A registry is an official database that records carbon credits. This produces the registered carbon credits. The defining property of this workflow is that there is no manual re-entry between steps. In a traditional system, people type data into spreadsheets by hand. In a dMRV system, data flows automatically from capture to issuance. Because the data moves automatically, dMRV maintains continuous audit logs. A continuous audit log is an immutable, time-stamped record of every action taken on the dataset. Immutable means it cannot be changed or deleted. This fundamentally changes the verifier's job. A verifier is the person who checks the data. In the past, verifiers had to reconstruct scattered records. They matched disparate spreadsheets and chased down missing receipts. Now, verifiers review structured data. They examine a unified, machine-readable database where every change is tracked. Structured data is data organized into a predefined format. This makes it easily searchable by software. Scattered records are unstructured files like emails and handwritten logs. These require human interpretation to piece together. Reviewing structured data allows verifiers to query the entire dataset and test for completeness. However, it is vital to be explicit about what digitisation does not fix. Technology cannot correct a wrong project boundary. A boundary is the physical or operational limit of a project. If the boundary is wrong, the sensors will merely record the wrong activity with great precision. Digitisation also does not define an undefined indicator. An indicator is a specific metric used to measure performance. If the methodology does not specify what to measure, the system has nothing to capture. Furthermore, dMRV cannot rescue an unapproved methodology. A methodology is the set of rules a project follows to calculate emission reductions. If the rules are wrong, the digital system will just calculate the wrong numbers quickly. Digitisation cannot fix bad rules. It can only apply the rules faster. You must ensure the rules are correct before you apply digital tools. Digital MRV also cannot substitute for absent governance. Governance is the system of rules and oversight that controls a project. A blockchain ledger entry of a wrong number is still a wrong number. If human oversight and institutional rules are missing, the digital system simply automates the failure. It makes the failure happen faster and harder to spot. This is why human judgment remains essential. Technology is a tool, not a replacement for good management. You still need people to check the system and make key decisions. The digital system provides the data, but people must interpret it and act on it. Without good governance, the data has no real value. You must build strong rules around the technology to make it work. To illustrate the shift from estimated to digitized measurement, consider a real example. This is metered cookstove monitoring. Under a gold standard metered methodology approach, sensors are attached to stoves to record actual usage. Emission reductions are computed from these measured cooking events. In the past, projects estimated these reductions from periodic household surveys. This is the clearest real illustration of the difference between an estimated and a metered indicator. The sensor provides a continuous stream of structured data. This eliminates the need to rely on memory or survey sampling. Note that as a consultant, you must always refer to the primary methodology document. You need this document for specific numeric parameters or version requirements. These details change over time, so you must check the source. As dMRV matures, institutions are beginning to define what good looks like. The World Bank's Carbon Markets Infrastructure Working Group produced a technical guidance note on standardizing digital MRV. This guidance note includes evaluation criteria for assessing system performance. It also helps identify where digitization adds value. It provides a framework for consultants to evaluate a proposed digital system. You can use it to check if a system actually improves data integrity. Sometimes, a system merely adds technological complexity without real benefits. The guidance note helps you tell the difference. It gives you a clear set of standards to measure against. This is how the industry moves from experiments to reliable systems. You should use this note as your guide when you review any digital system. Crucially, dMRV is now moving from pilot projects to governed infrastructure. We can see this in a real, dated example from the Global Carbon Council. The Global Carbon Council is a standard body. It has established a dMRV solution provider approval procedure. This is described as a first in the voluntary carbon market. Under this procedure, a standard body defines tracks and sectoral scopes. It also grants provisional approvals. This means a platform's outputs can be relied upon in the issuance process. As a matter of record, the platform trace is the first approved dMRV platform. NextGreen or NextGreen Tech Limited developed this platform. The Council introduced it at a webinar on the 4th of May, 2026. NextGreen Tech Limited holds provisional approval under Track 2. This covers energy generation, transmission, distribution, and energy efficiency. The teaching point here is the approval procedure itself. It shows that standard bodies are now creating formal governance structures for digital systems. They no longer leave project developers to rely on unverified vendor claims. However, you must remember the boundary between institutional approval and commercial marketing. The approval shows a platform's outputs can integrate into a registry. It does not mean any specific platform is inherently superior to alternatives. It also does not guarantee verification or issuance. As a consultant, you must teach the technology category and its failure modes. You must recognize that sensor drift and calibration loss are real engineering realities. Cloud cover and resolution limits affect optical remote sensing. Silent failure in automated data pipelines can also happen. A silent failure occurs when a system stops recording data but does not alert anyone. This leads to gaps in the record. An immutable ledger entry of a wrong number is still wrong. Your role is to ensure the digital system has robust oversight. To finish this module, You should complete a practical task. Review the World Bank Technical Guidance Note on Standardizing Digital MRV. Also review the Global Carbon Council dMRV Solution Provider Approval Procedure. Then, produce a one-page gap analysis. Compare a client's proposed digital data pipeline against the evaluation criteria in these documents. Check it against the governance requirements as well. In your analysis, explicitly identify where the pipeline relies on unverified vendor claims. Point out where it lacks institutional approval. This task will help you apply the principles you learned in this module. It will show you how to evaluate digital systems in the real world. You must base your assessment on facts and official rules, not on marketing promises. This is how you build trust in carbon markets.